Hello class, in this lesson I'm going to explain to you the exercises from page 96 from our book, and these 5 exercises are about work and power. I haven't explained to you what power is. I'm going to do it next so that we can solve all of these 5 exercises. Now, by the way, I'm not going to explain them all. I'm just going to do for you the first one, the second one, and the third one. And problem number 4 and 5 are going to be done by you as homework. So let's get started, guys. Ready? Okay, so let me just remind you about what work meant. If we remember, guys, sorry about these interruptions, guys. I was sneezing, so I had to pause the recording. So I was telling you, let's first remember what the concept of work is. So when you have a particle, that's my little particle, and when you apply a force on this particle, let's suppose we apply a force in this direction, and also this particle has a displacement. Let's suppose in this case the displacement goes along the same direction as the force. Remember that usually displacement is represented by an x. Then these two are vectors. Both the force and the displacement are vectors because they are quantities that both have magnitude or size and direction. And then we said that the work done on this particle is defined as the multiplication of the force, the magnitude of the force times the magnitude of the displacement times the cosine of a specific angle. And this angle is the angle between the force and the displacement. When the force and the displacement go in the same direction, in other words, they are parallel, the angle is 0 degrees. When they are not parallel, for example, what happens when we have the force pointing in this direction and maybe the displacement pointing in this direction? What we have to do in order to find the angle between these two vectors is put them tail to tail. So you can grab one of the vectors and you can displace it so that the tails of both vectors coincide in this way. Be careful because you cannot rotate the vector. You have to displace it following the same direction as before. And now that they are tail to tail, this is the angle that they make in between, right? Another example, the force points, well, let's draw the force pointing in let's say this direction. This is the force, this is the displacement, it goes upwards, and the force goes leftwards, and the same idea. Now I'm going to choose the force and I'm going to move it towards the tail of this vector, and it's going to look like this, and thus you can see that the angle that they make in between is this one, which seems to be 90 degrees. So that's what we mean by the angle between these two vectors. Okay, so that's the definition of work, guys, and we already did some examples about this concept. Now, what is power? By the way, power is translated into Spanish as potencia. We don't say that this is poder. I know that power is usually translated as poder, but in the context of physics, it's translated as potencia. So what is power? The definition of power is very simple, guys. The power is just the work done over a period of time. What does this mean? What does this mean? I'm sorry. What this means is that basically power is just how fast work is done. How fast work is done. That's why it's defined in this way. It's the amount of work done over the time in which this work was performed. For example, if let's suppose that you have two people. One person is gonna push this object with a force of, let's say, 10 newtons and over a displacement of 1 meter. Let's keep it very simple. This is person A, and person B in here is gonna push the same particle, okay, the same mass, with the same force, a force of 10 newtons, let's suppose, over the same displacement in the same direction as before, the same displacement of 1 meter. The only difference between these two people is that the person A is gonna do this action in, let's say, 5 seconds, and this other person is gonna do this action in 10 seconds. And what I mean by action, the action of pushing this particle with this force over this displacement. Okay, so let's calculate the work done by the person A. The work done is the force, which is 10 newtons, times 1 meter, which is the displacement. And as I told you before, since the vectors are parallel, then the angle between them is 0 degrees. When you calculate this, you will get a work of 10 joules. So this is the work done by the person A. And the same is going to happen, since I have the same values, the same is going to happen for person B. The person B is going to do the same work on this particle. So both people do the same amount of work on the particles, on the same particle. Okay, what is the only difference? The time in which both people do such work. So for example, let's calculate the power developed by the person A. The power will be the amount of work over the time in which this work is performed. So the amount of work was 10 joules. How much time? 5 seconds. So this is equal to 2 joules per second. So this is the power developed by person A. And the power developed by person B is going to be the amount of work, which is 10 joules, over the amount of time, which is 10 seconds. And this is 1 joule per second. So as you can see, guys, the only difference between both situations is the power, the amount of the amount of power developed. This person develops 2 joules per second, and this other person develops 1 joule per second. Okay, so that's power, guys. It's just how fast we do work. And in this case, person A does work faster because it's doing, both people are doing the same work, but this person is faster, right? Because he's doing it in 5 seconds, and this other person is doing the same work over a longer period. So that's why his power is less than the power developed by person A. So that's the idea behind power. And the only other thing that I want to tell you about power is that we can define another quantity, just like we did with work. If you remember, we defined Newton. We defined 1 Newton times 1 meter as 1 joule. All right, this was for work. In the same way, we can define another unit or an abbreviation of this unit, which is joule per second. We can define the following: 1 joule over 1 second is going to be defined as 1 watt. Perhaps you have heard this word already in your electric bills or something like that. Okay, or in, I don't know if you have a toaster. Just try to see, if you have a toaster, a bread toaster, try to see that at the base of that article, and you will see that they're gonna tell you something about watts. So basically they're telling you about the power that this thing can deliver, la potencia que tiene el electrodoméstico. Okay, so let's get started with these 3 examples. So the first one, Calculate the work performed when a person pushes a trunk over a horizontal surface along a distance of 20 meters, applying a force of 50 newtons in the same direction as the movement. Okay, so in this case, guys, what do we have? We have a horizontal ground or horizontal surface. We have a trunk. What is a trunk? I think it's a box. I think it's the same as a box. So it doesn't matter. It's just something, right? It's just a particle. And then a person is going to push it horizontally towards the surface. Whether you choose it to the right or to the left makes no difference, because the problem is not telling me the direction of the motion. So it doesn't matter. It doesn't matter. Okay, so let's draw the vector of force over this particle. So let's choose the forces being applied to the right. Okay, and then they tell you that this force is in the same direction as the movement. So let's draw the movement or the displacement also in the same direction. Okay, we have the vector of force, the vector of displacement, and therefore we can already see right away that we have the force, which is 50 newtons. We have the displacement, which is 20 meters. The angle between these two vectors is 0 degrees, given that they are parallel, and we have all the ingredients to calculate the work. So the work is force times displacement times the cosine of the angle between them. Then just substitute 50 newtons times 20 meters times the cosine of 0 degrees, and you will get 1000 joules. And this is the result. A very simple thing for a very simple problem. Period. That's it, guys. Okay, let's move on. You can pause the video and analyze what I said as many times as you want. Second problem. What do we have here? We have a horse dragging a bulk of cement. So this is my particle, a bulk of cement. And he's dragging this bulk of cement on the floor, and the horse is dragging it with a rope that forms an angle of 42 degrees with respect to the floor. So let me stop right here, guys. You don't have to read the whole thing before. You can actually draw a diagram or something. So same idea. I'm going to draw my horizontal surface. I'm going to put my particle here, which is my bulk of cement. And what's happening? A horse is dragging, arrastrando, this bulk of cement with a rope that forms an angle of 42 degrees with respect to the floor. So I'm gonna represent the rope in red. So we have the bulk of cement, we have the rope, and we are told that this rope makes an angle of 42 degrees with the floor. Perfect. Let's continue. The horse drags this particle, applying a force of 180 newtons. So let's already put that in here. The force is 180 newtons through the rope. So basically, guys, I mean, it's pretty easy to understand that the force is being applied along the direction of the rope. The force is being applied in this direction, right? Because the force is being transmitted by the rope. So the force that is being applied on this particle follows this direction. Okay, perfect. Now, what is the question? The question is, what is the work developed by the horse if the distance the bulk travels is 8 meters? Now, in what direction is the displacement of the particle, guys? Since it's being dragged, that means that we are dragging it along the floor. I know that the direction of the force is this one, but if you think about how this could happen, you know that the bulk of cement has to be traveling in this direction, right? It's gonna be traveling still in contact with the floor. So this is the direction of the displacement, you see? and we are set that the displacement is 8 meters. Okay, and now I just need the angle between the force and the displacement, right? Between this vector and this vector. What is the angle? Well, as we can see, it's 42 degrees. So there it is, and we have the force, we have the displacement, we have the angle between them, and therefore we can calculate the work. I just write the formula, I just substitute the values that I had, and I calculate this times all of this. So let's use the calculator and let's see what we get. We are gonna get 1070.12 joules. That's it. Okay, and that solves this problem. So let's continue, guys. The next problem is a little trickier. This one, problem number 3. So I want you to stop the video, guys, for a moment. I want you to pause it and read this problem 2 or 3 times until you understand what's happening. Okay? All right. So let's continue. So in here, guys, after you have read the problem 2 or 3 times, what you must understand is that the construction worker is pushing this load in 2 different ways, or following 2 steps. That's a better phrasing. What's happening in this problem? How can we depict in graphically what's happening here? What is happening is this, guys. We have a load, una carga, and some construction worker is gonna push this load of 60 kilograms. We have the mass, so let's write that down. 60 kilograms. First, he's gonna push this load over a distance of 14 meters along the floor. What that means is basically horizontally. So first he's gonna push it in this direction with some force and over a certain displacement of 14 meters. So let's write that. The force is 260 newtons and the displacement is 14 meters. And the angle between the force and the displacement, as represented graphically, the angle is going to be 0 degrees. Okay. And then after this, guys, once this has been done, then he's going to raise the load vertically upwards. But let's pause right here the problem and let's already calculate how much work this person has done by doing this first step only. So the work in this first step of the problem is gonna be force times displacement times the cosine of the angle, and therefore you just have to substitute these values in here. Like so. So let's calculate this expression, and we are gonna get 3,640 joules. So this is the amount of work done in this first period, in this first step of the problem. Okay, then, like I said before, we have a second part of the problem, because after this worker has done this, then he's gonna raise the load 1.2 meters from the floor. So now the worker is gonna apply a force. Well, I think this is better. I think it's better to draw it separately. So now the particle is gonna be here. It has already traveled from, let's say, over here to here, in this first part, and now that that is at this location, now the worker is gonna raise it upwards. It's a vertical motion. So basically, in order to do that, the worker has to apply a force vertically so that the particle can raise also vertically. And now let's find the force in the displacement for this part of the problem, because it's not gonna be the same as these two quantities. In this part of the problem, the force is, if you look in here, guys, you're not gonna be given the force, and I'm gonna tell you why. If you look at this second part of the problem, starting from here until the end, you won't find this force, and I'm gonna tell you how to find it in a moment. But we do know the displacement. The displacement is 1.2 meters. 1.2 meters, and we also know the angle, because once again, both vectors are parallel. And I've been telling you that when that happens, the angle is 0 degrees, because when you put them tail to tail, if you draw the force and then you draw the displacement, let me use another color. If you put them tail to tail, you will see that the angle that they form is actually 0. It's nothing. You see, it's 0 degrees. So if I wanted to calculate the work done over this part of the problem, guys, at this point, I'm not being able to do that because I'm lacking the force. We don't have the force yet. So what's up with that? How can we find this value? Okay, it works in this way, guys. If you notice, this piece of information has not been used. The mass of the particle, even though they gave it to me at the start of the problem, I haven't used it. So why did they give me this value? Well, they gave it to you because of the following. When you want to raise, and I'm going to explain to you this concept over here. When you want to raise a particle, guys, from the floor, when you want to raise it upwards, the question is, how much force do you need? How much force do we need to raise a particle? How much force? And I'm going to explain to you how much you need. The first thing you have to consider is this, guys. This object and any particle whatsoever, not only this object in this problem, but any particle in any problem. What you must notice, guys, is that there is a force being applied on this particle, and that force is the force of gravitation applied by the Earth. And if you remember, that's what the weight meant. I've been telling you that the weight of any object, represented with this arrow and this letter for weight, the weight is the force with which the Earth attracts the particle towards its center. You see, so basically the Earth is pulling downwards this object. With how much force? With the force given by the weight, which is the mass of the object, the mass of this object, times the acceleration of gravity. Okay, so for example, let's suppose that this particle in particular has a mass of 10 kilograms. Then the weight of this particle is going to be 10 kilograms times 9.8 meters per second squared. I'm not sorry about this, it's not fitting. And then the weight is going to be, when you calculate this, the weight is going to be 98 newtons. So that's the weight of this particle. And if you want to lift it, guys, if you want to raise this particle so that it starts moving upwards, you need to apply at least as much force as its own weight. For example, if you apply just a force of 10 newtons upwards, then the particle will remain in its place, because the force that you're applying upwards is less than its own weight. The same is going to happen if you apply, let's say, 97 newtons upwards. Since this is less than the weight of the particle will remain touching the floor. So it is when you cross over 98 newtons At 98 newtons, you can already start to move the particle barely. And any other thing, any tiny force greater than 98 newtons will cause the object to elevate, basically. So we might say that this is the minimum force that we need to apply. This is the minimum force that we need to apply to this object so that it starts to being lifted. And how much is this force? It's going to be always the same as its weight. If you have another particle in here which has a weight of 200 newtons, then the amount of force that you need to apply upwards in order to elevate this particle from the floor is at least 200 newtons, the same as its own weight. That's how it works. So with this explanation, guys, which I can erase now. So basically, if we want to raise something from the floor, we need to apply a force which is at least the same as its weight. So if I want to raise this object in here, now let's go back to the problem that we were working with. If I want to raise this object, I need to apply a force equal as its own weight. And how do I calculate the weight of this object? Well, we have the mass. So let's calculate the weight of this particular particle. It's going to be its mass, which is 60 kilograms, as represented in here, times the acceleration of gravity, 9.8 meters per second squared, and thus the weight will be, let's calculate it, 588 newtons. That's going to be the weight of this load. Okay, so let's represent that with this arrow. That's the weight, and it's going to be 588 newtons. So how much force do we need to apply upwards? What should be the magnitude of this force? The same as its weight, like that. And that's how you can find this value, guys. For this type of problem, when you want to raise something from the floor, you can find the force, the necessary force, by this piece of razor. Okay, so that's it, guys. We can find the work now. So work is going to be equal to 588 newtons times the displacement, which is 1.2 meters, times the cosine of the angle, which is 0 degrees. Let's calculate all of this thing, and we should get 705.6 joules. There you go, guys. So let's recapitulate. The worker first performs this work over this horizontal distance, and then now that the particle is here, he's gonna raise it. So basically this worker is doing work, or he is performing work in two separate events, or at two separate parts. So now that we know this, what is the total work done on the load? The total work is, of course, the sum of the first work done and the second work done. Let me address that in yellow. So the total work is going to be equal to this much plus this much, and let's make that sum. We're going to get 4,345.6 joules of total work. So that solves my first question in here. Why do I say the first question? Because they're asking me something else. They're also asking me, what is the power developed? What is the power? This is the new concept that I told you about at the introduction of this lesson. And all we have to do is remember what the definition of power is. I told you that power is how fast work is done. In other words, the amount of work done over the time in which such work is done. They tell you guys that all of this is performed in 3 minutes. The pushing horizontally and the raising vertically. All of this takes 3 minutes. So that's all we need, the time. But remember, you need to transform to seconds because minute is not the official unit in the SI for time. So always use kilograms, always use seconds, and always use meters. If you're given any other quantity which is not in these three units, convert it immediately. How many seconds are 3 minutes? Well, it's gonna be 100 seconds, right? Pretty simple. And that's it, guys. That's all we need. Then we can calculate the power developed throughout all of this motion from here to here and then from here to here. The power will be the total work performed, which is this much. It's the total work over the total amount of time, which is 180 seconds. We calculate this value and we get 24.14 joules per second. And I told you that when you have the unit joules per second, you can abbreviate as watts. You can leave it like this, that's perfect, but you can also use the word, well, the unit watts. So the power developed in this problem, guys, the power developed by the construction worker is 24.14 watts. And that solves the problem completely. Okay, guys, so now you try on your own problem 4 and problem 5, because I'm going to ask you in the next lesson that we have live, I'm going to ask you for the answers of problem 4 and problem 5. And that settles this lesson, guys. Thank you so much. Have a good day and see you later.